No. So what are the forces that are acting? So what is the mass of them? M into M. So show that one. This is mg. Capital letters, sir. They're capital letters. This is the thing. Then half of the volume you must know. So what is the density of the liquid? Rho. So let me directly write it. It'll be easy for me. Rho Vg. So volume also is given. Capital V, that is. So the bind force are equal. Then afterwards, there's a particle which is mg. So this distance is what? Is saying small l. This distance is what? Capital T. It's very simple problem. So half of it is immersed in liquid. What changes the value of m is tell? It's in equilibrium. I think there's a light rod. It's in equilibrium. For equilibrium, what is the basic condition? Net force should be 0. So for that, so the first equation will be 2 rho Vg minus
So
mg
it is rho V by 2 G, no, sir.
V by 2. Off is immersed. Okay, thank you. Yeah. Then this should be only rho Vg. 2 mg minus small mg equal to 0. So this will become rho v minus 3m equal to small m. I think answer over. See, like we do get scared suddenly something new, rod, two bodies connected. Get into the problem, draw the diagram, show the forces, then some, okay, what can be done? See, anybody, human being, what happened? The moment you see question, nothing will flash, but read question, draw the diagram, show the forces. Is it equilibrium? Is it in motion? Any torque is acting? Is it moving? Is it accelerating? Or is it rotating? Identify, then write some equation. Then okay, now you have to analyze, okay, what can happen further? So students, what they're doing, they're reading question, finish, sure, that's all finished. And they think that something, uh, something should flash to the question. Nothing, there's no flash, nothing. Read question, draw the diagram, show all the forces. Then look at the, is it equilibrium or it is moving? Or it is translative motion, rotative motion, or equilibrium, or having both translative, rotative. Corresponding to that, write equation. Finish all. You can, we can manage to some extent. Okay, now the value of L. So it's in net, as it is in equilibrium, so net torque should be 0. About what point? So since he's asking the value of L, so shall I go for in terms of anything? So directly about 0.0, we can go for it. About 0.0, or if you want, if you about small m, so directly about 0.2. Net torque should be 0. Should be 0. Okay, what are the things? Mg into d minus L capital Mg d minus L. This should be the anti-clockwise. Rho Vg by 2 should be clockwise. 2 mg L clockwise. Rho Vg by 2 L anti-clockwise. Solve it, we'll get expression for L. But we don't know. I think not needed. No, he's asked everything in terms of capital M and rho V. Okay, I think this will be sufficient. So can I apply torque about point A also? Anything, if you want, you can even do also. Net torque about A, 0. Net torque about B should be 0. About any point, you can apply it and solve it, you'll get the required answer.